Now we'll start with lecture number 3. In this lecture, we are going to see how we can solve system of linear equations by numerical methods. Okay, so firstly we'll see what do you mean by this system of linear equation. If you are having number of equations, suppose 3 equations in 3 unknowns, okay, then that equations, the system or that set of equation generally denoted by some constant into x1 plus constant into x2 plus constant into x3 equal to b1, a21 x1 plus a22 x2 plus a23 x3 equal to b2, again some constant into x1, a32 into x2 plus a33 into x3 equal to b3. If you have 3 equations in 3 unknowns, 3 linear equation, power of each term is 1, so it is called as a linear equation. If you are having number of equations and the number of unknowns, 3 unknowns are there, then such type of equation, such type of collection we call as a system of linear equation. These are 3 equations in 3 unknown. Like that we may have 4 equations in 4 unknown, 2 equations in 2 unknown. Okay, and we are going to see how to solve such type of equations by using different techniques. Okay, the previously we saw single equation, and that may be either a polynomial or transcendental equation, but here we are having number of equations and number of unknowns are equal, and power of each variable, power of each unknown is 1. That is, it is a linear equation. Okay, so how to solve such system, solve such set of equations, okay, that will be covered in this lecture. Okay, now there is one simple way in which we can represent this system, and that is nothing but the matrix form. This we can write in matrix form as, just take the first column as coefficients of x1, a11, a21, a31. Then take second column as coefficients of x2, coefficient of x2 in first equation, second equation, third equation. That will form the second column, and the coefficient of x3 in each equation, that will form the third column. Okay, take all unknown terms x1, x2, x3 in one column and equate with the all the terms which are on the right hand side of the equation, all the constant terms, that is b1, b2, b3. So this is nothing but the matrix form of this system. If you're having 4 equations in 4 unknown, we get this as 4 by 4 matrix. Then this will be 1 x1, x2, x3, x4, and here we get b1, b2, b3, b4. Okay, now we can write this system in matrix form, because if we know the properties of matrix, if we take the multiplication of these two matrices, then how we take the multiplication? We take this first row and we take the first column of this, then multiply the corresponding elements. So it will be a11 into x1 plus a12 into x2 plus a13 into x3, and that first element will be equal to this first element b1, and that is nothing but this first equation. Same way, if we take the second row and this first column, if we multiply them and equate with the second element, it will give us the second row, and this third row and this first column corresponding multiplication will equate it to b3, and it will give us the third equation. So any system of equation can be easily written in matrix form. Okay, actually we can solve these equations directly, but if you write it in matrix form, then doing calculation become very easy. Okay, so matrix form is preferable while solving these equations. Okay, now each matrix has some name. This first matrix we call as a matrix of coefficient. This matrix is called as a matrix of unknown, and this matrix is called as a matrix of constant term, and this is generally denoted by ax equal to b. Okay, a is all these coefficients, x is all unknown, and b is all these constant term. There is one more simpler way to write this. Unknown terms you can skip, you can just take the terms with which we are doing the calculation, that is all these a terms and all these b terms, and if we combine this a and b terms, then That type of matrix is called as an augmented matrix. It is a matrix in which all A's and B's are there, just separated by a line. Okay, and that is denoted by AB, matrix AB. This we call as a augmented matrix AB. Okay, all elements of A, all the elements of B, just separated by a vertical line. Okay. Now, what are the different methods are there to solve these linear equations? Already in school level or in 11th, 12th or in diploma also, you have learned some of the methods. That is by using inverse method. Okay, finding the inverse of a matrix and multiplying with matrix B. X will be A inverse into B. Okay, like that, by using Cramer's rule also we can solve the system of equations. Now in this we are going to learn some different methods to solve the system of equation. Mainly there are two types of methods. The first type of method is a direct method. In this direct methods we are going to see what is a Gauss elimination method, then triangular factorization, or it is also called as LU decomposition method. Then we are going to see Cholesky's method, and the other type of method is indirect method, or it is also called as a iteration method. And in this method we are going to see two methods, that is Jacobi iteration method and Gauss-Seidel method. Okay, so in this chapter we are going to see these 5 different methods. So these 3 direct methods and these 2 iteration method. Okay, iteration means we try to find the new terms, new values of x1, x2, x3 by doing the iterations, and we compare it with the previous value and we match that previous and the next value. And depending on the conditions given in the problem, we find the answer which maps up, which matches up to 2 decimal places or 3 decimal places. Okay, that is how this iteration method can be done. Okay, so one by one we'll see all these methods. The first method is Gauss elimination method. Now what we do in Gauss elimination method, this can be solved directly by the equation, or you can use matrix form. So we'll see this by using the matrix form. In this method, what we do, whatever system of equations are given, we firstly write it in matrix form. Then we try to convert it into upper triangular form. Now what is the upper triangular matrix? Upper triangular matrix means all the elements below diagonal are 0. Okay, and then doing the back substitution we can get the solution of it. Okay, and how it can be converted to upper triangular matrix, we can use different row operations or row transformations. Okay, so while finding the inverse, we use different row transformation. We can interchange 2 rows, we can multiply any row by constant k, or we can multiply any row by k and add it to other row, that is ri plus krj. So these are the main 3 operations we can do with rows of any matrix. Okay, and by using that row transformation, row operation, we have to convert this matrix into upper triangular matrix, and that matrix will be like this. Okay, these elements are called as a diagonal elements, a11, a22, a33. All the elements below that, if all the elements below that are 0, then it is called as a upper triangular. So by using different row operations, we have to convert it into upper triangular form. Then from this matrix, again we have to write the equations. By using last row, we get the value of the last unknown term, put it into previous, that gives us the value of next unknown term, put both these unknown values into previous, it gives us the value of the remaining unknown terms. Okay, so here no separate formula to remember for this Gauss elimination method. Firstly, we have to convert that matrix, convert that system into matrix form, use different row transformation and convert it into upper triangular form. And then from this matrix, again write down the equations and then solve that equations by using these. We can easily solve that equations, and that gives us the unknown term. Now, these elements A11, A22 dash, A33 dash, these elements are called as a pivoting elements. Okay, the first non-zero elements, the first non-zero element of that corresponding row is called as a pivoting element. Okay, so this is a Gauss elimination method. Okay, now there is one method similar to this, means making use of this method only. We can do some more simplification, and that is done by using partial pivoting. Now, what is this partial pivoting method? Okay, it is a Gauss elimination method only, but in this we have to do firstly some steps. What are that steps? We have to check in all equation coefficient of x1, in which equation the coefficient of x1 is largest. Then take that equation as the first equation. In Gauss elimination, we directly start reducing it into upper triangular. But in partial pivoting, we have to search the equation in which coefficient of x1 is the largest. Then take that equation as the first equation. Okay, and then make the coefficient of that equation 1 and remove x1 from the other equations. Okay, then uh, in the second step, means after removing x1 from the other equation, exclude this first equation, and from the remaining equations, check which equation is having the largest coefficient for x2. Then take that as a second equation, and from that get the value of x2, remove that x2 from the remaining equations, and like that we have to continue. Okay, so what to do? First of all, check out the system of equation which are having the largest coefficient for x1. Take that as a first equation. Make use of that equation, remove x1 from the other two equations, or if you write it in matrix form, then get 0 below that first element. Okay, if you write in matrix form, and if you want to solve directly, make the coefficient of x1, and making use of that equation, remove x1 from the other two equations. Okay, then whatever remaining equation, remove this first equation, whatever remaining equations. Okay, in that check in which equation the coefficient of x2 is the largest, and take that as the second equation. Then make the coefficient of x2 1, remove x2 from the remaining equations. Then in the remaining equation, check which equation has the highest coefficient for x3. Take that as a third equation. Like that we have to continue. Okay. Here for Gauss elimination, we doesn't do any interchange. Whatever equations are there, we take them in same order. But for partial pivoting, we interchange the equation so that the coefficient of first equation become largest. That is the only change. Otherwise, rest of the things are exactly same as Gauss elimination method. Okay. So we'll take a problem, then you understand this better way. So consider the first problem. Solve the following system of equations by using Gauss elimination method. Okay, 2x plus 4y plus z equal to 3, 3x plus 2y minus 2z equal to minus 2, x minus y plus z equal to 6. Okay, so we are having three equations in three unknowns x, y, z. So what we do, firstly, we'll write it in the matrix form. Okay, so better way, firstly, you can directly write down the augmented matrix. How to write the matrix? Take the first element as a coefficient of x from each equation, 2, 3, 1. Second column will be the coefficients of y in each equation. This is 4, 2, minus 1. Then third column will be coefficient of z. Here coefficient is 1, minus 2, 1. We are using augmented matrix, so no need to write what are xyz column. You can directly write the constant terms, 3, minus 2, and 6. Okay, we are directly writing the augmented matrix, so no need to write the uh, matrix XYZ. Okay, now what to do? We have to convert this matrix into upper triangular form. And what is the easy way to make it into convert it into upper triangular form? Try to make this first element 1. Now here to get 1, the easy way is just divide this equation, divide this first row by 2. And that we can do by using the row transformation 1 by 2 into R1. Okay, we can make first row, first column element 1 by using 1 by 2 into R1. R1 denotes first row, R2 second row, R3 third row. We want to make this element 1. Okay, so that can be done by dividing this first row by 2. So the first row operation we are doing 1 by 2 into R1. So it becomes 1, 4 by 2 is 2, 1 by 2, 3 by 2. Rest of the elements, keep it as it is. Now we want 0 below it. Okay, after getting 1, bring 0 below it. How to get 0 here? You can make use of this equation. It will be second row minus 3 times first row. Okay, R2 minus 3 times R1. We want 0 here also at the third row. So to get 0 here, just take the just subtract first row from it. That will be R3 minus R1. So we do two operations, R2 minus 3R1, R3 minus R1. By that we get 0, 0. So it will be R2 minus 3R1, R3 minus R1. So do the corresponding changes in the rest of the elements also. So it becomes 3 minus 3 into 1, 2 minus 3 into 2, minus 2 minus 3 into half, minus 2 into 3 into 3 by 2. That gives us these elements. R3 minus R1 will be 1 minus 1, minus 1 minus 2, 1 minus half, 6 minus 3 by 2. Okay, we are using this operation to get these elements. Okay, and if we solve this equation directly without matrix, then what we'll do, we make the coefficient of x1. Okay, how we make the coefficient of x1? Just by dividing by 2. That is this operation. After getting x here, we have to remove x from these two equations. Okay, why this is called as a Gauss elimination? Because we find the value of one variable and we remove from other equations. We eliminate it from other equation. And how we can eliminate x from this? We make use of the first equation. When the coefficient of this is 1, then we take second equation minus 3 times first equation after making this coefficient 1. And when the coefficient of this is 1, we take our third equation minus first equation. That is nothing but R3 minus R1. So you can do it in matrix form or you can do it directly. Make the coefficient of x 1 and then making use of this first equation, remove x from these two equations. And that is nothing but these steps. Okay. So matrix, it become quite easy because we doesn't have to write x, y, z again and again. So this form become easy to do the calculation. Okay, so whatever we are doing directly, that we are writing in matrix form. Now, leave first equation, just consider the second and third equation. Make this coefficient 1. Bring 1 over here. Okay, because we want this will be the coefficient of y term. We have to remove y from the other equation. And to remove y, it is better to make this coefficient 1. So to make this 1, divide it by minus 4, multiplied by minus 1 by 4. Okay, so the next term become minus 1 by 4 into second row. So it will be 0, 1, 7 by 8, 13 by 8. Rest of the elements are as it is. Only change in the second row. All the elements of second row. Rest of the elements keeping as it is. Now we want to remove y. So to remove y, we have to make 0 here. And to make 0 here, make use of this second equation. It will be R3 plus 3 times R2. Okay, multiply this by 3 and add it to this. By that, this becomes 0. And that can be done by third row plus 3 times second row. So the next operation will be R3 plus 3R2. Okay, so now you can see that it become upper triangular matrix. Okay, so that is the that is what we want. Firstly, we got the equation in x, y, z. Then we got the equation in y and z, because this is 0, so no x term will involve in that y and z. And then next we eliminate y and we get the equation in z. So at each step we eliminate one variable. Bringing 0 means that coefficient means that uh, unknown term will be eliminated. Because of that, it is called as a Gauss elimination method. Now, use this matrix. If you want, you can make this term 1, or you can take this matrix as it is and write down the equations again. Now, from equation, we know how to write the matrix. By exactly reverse way, write down the equations from this. So how we write the equations? These are the coefficients of x term. Second column is a coefficient of y. Third column is a coefficient of z. And all these are the constant term. So the equations are 1 into x plus 2 into y plus half into z equal to 3 by 2. I just bring exactly reversed way. Then next equation will be 0 into x, 1 into y, 7 by 8 into z equal to 13 by 8. Next equation 0 into x plus 0 into y plus 25 by 8 into z equal to 75 by 8. Okay. Okay, these are 0 means, so that term we doesn't write. 0x plus 0y, it will be 0, so no need to write it. Okay, so we get these three equations. Now we have to do back substitution. Get value of z from this third equation, put that z into previous, get the value of y, put y and z into this equation and get x. So from this 8 get cancel, z will be 75 by 25, that will be 3. Put that z equal to 3 over here, so it will be y plus 7 into 3 by 8 equal to 13 by 8. Take all the terms on other side. So it will be 13 by 8 minus 7 by 3 into 7 by 8 into 3. That comes up to be minus 1. And x will be 3 by 2. Using this first equation, 3 by 2 minus 2y minus z by 2. So put that y and z over here. That gives us the answer 2. So the solution of that system is x equal to 2, y is equal to minus 1, and z equal to 3. Okay, so carefully remember the method. Here we are not using any formula as such. We just write the given system into matrix form. Then we try to convert that system into upper triangular form. And how to convert it into upper triangular? Make the coefficient of first equation, first row 1, then bring 0 below it, then second row, second column 1, below that 0, and then write down the equations from it and solve that by doing back substitution to get the values of unknown term. Okay, so this is very easy and very important one. By making use of proper row transformation of matrix, we can easily get the answer. Okay, now consider the next problem. Solve the following system of equation by using Gauss elimination method. 3x plus 2y plus 7z equal to 4, 2x plus 3y plus z equal to 5, 3x plus 4y plus z equal to 7. So again, first write the augmented matrix of this augmented matrix from the system of equations. In first column, all the coefficients of x term. Second column will be the coefficients of y from all the equations. Coefficient of z from all these equations. And on this side, all the constant terms 4, 5, 7. Now, try to convert this matrix into upper triangular form. For that, make the coefficient of this first row, first column element 1. This element try to bring 1. We can bring 1 here by dividing this third row by 3. So or multiplied by 1 by 3. So that is 1 by 3 into R1. Okay. So it is 1, 2 by 3, 7 by 3, 4 by 3. Rest of the rows are as it is. Now, after getting 1, bring 0 below it. That will be this minus 2 times first equation, this minus 3 times this row. So it will be R2 minus 2 times R1, R3 minus 3 times R1. By that we can get 0 here. Okay, so do that corresponding changes. R2 minus 2R1, R3 minus 3R1. So it will be 2 minus 2 times 1, 3 minus 2 times 2 by 3, 1 minus 2 times 7 by 3, 5 minus 2 times 4 by 3. That gives us the second row. By using this, there is a change in the third row. It will be 3 minus 3 times 1, 4 minus 3 times 2 by 3, 1 minus 3 times 7 by 3, 7 minus 3 times 4 by 3. That gives us the next row. Okay. Now after getting this, try to make this second row, second column element 1, and this we can make it 1 by multiplying it by 3 by 5. Here we have 5 by 3, but we want it 1. So multiplied by 3 by 5. So multiplying it by 3 by 5. So second row become 0, 1, minus 11 by 3, and 7 by 5. Rest of the rows are as it is. Okay, 1, 2 by 3, 7 by 3, 4 by 3, 0, 2, minus 6, 3. These rows are as it is. Only change in the second row by such operation, 3 by 5 into R2. Okay. Now, after getting this one, bring 0 below it. We want 0 here. And this can be bring 0, brought 0 by taking this minus 2 times this row. That is R3 minus 2 times R2. So it will be R3 minus 2 times R2 will be 0 minus 2 times 0, 2 minus 2 times 1, minus 6 minus 2 times minus 11 by 5, 3 minus 2 times 7 by 5. So it will be the new row. If you want, you can make it 1 or you can keep it as it is. Write down the equations from that matrix and solve that equations simultaneously. Okay, so this is that upper triangular matrix we have. Write down the equations from it. X plus 2 by 3y plus 7 by 3 into z equal to 4 by 3. 0 into x, 1 into y, minus 11 by 5 into z equal to 7 by 5. And 0 into x plus 0 into y plus minus 8 by 5 into z equal to 1 by 5. Now from this last equation we get z. Put that z into previous to get y. Put y and z into previous equation to get x. Okay, so z is minus 1 by 8. Y will be 7 by 5 plus 11 by 5 z. That comes out to be 9 by 8. And x will be 4 by 3 minus 2 by 3y minus 7 by 3 z. Put these y and z over here. That gives us the answer x equal to 7 by 8. Okay, so these are the answer. X is 7 by 8, y is 9 by 8, z is minus 1 by 8. Okay, so important is writing it into matrix form, converting it into upper triangular by using row transformation, and then doing the substitution of variables into previous equation. This we call as a back substitution to get the values of all unknown terms. Okay, without matrix also you can solve it, but there we have to write x, y, z in every equation, and then it become very lengthy. So we use matrix form. In some books you may find that these problems are solved directly without matrix. Okay, but I prefer matrix because we get it become very easy to do the calculation, and we can without error we can easily do the calculation. Okay, that's why I use matrix form. Now consider the next problem. Solve the following system of equations by using Gauss elimination method with partial pivoting elements. That is x plus y plus z equal to 6, 3x plus 3y plus 4z equal to 20, 2x plus y plus 3z equal to 13. Now, here it is asked to use the partial pivoting. Now, what to do in partial pivoting? Now, the first step is same. We have to write the augmented matrix. Then, whichever equation having the largest coefficient for x, that equation we have to take it as the first equation. Now, which equation have the largest coefficient for x? For first equation 1, for second equation coefficient of x is 3, for third equation the coefficient of x is 2. So you can look at this first column, which are having the largest value, take that as a first equation. So here largest value is 3, among 1, 3, 2, largest is 3. So take this as a first row, and we can take this as a first row by interchanging these two rows. There is one property in there is one transformation we have, that is interchange of two rows, that we can do to get that term. So we are interchanging first row and second row, that is denoted by R12. R12 means interchanging of first and second row. Okay, so here this 116 becomes second row and 334 20 become first row. Okay, this is the operation called as an interchange of two rows. Okay, or we just make it as a first equation, this as a second equation, this as a third equation, just rearranging the equation. And rearrangement means interchanging of rows. Now make this coefficient 1, rest of the part will be same. Make this coefficient 1, divide it by 3, then bring 0 below it. To make 1 here, we divide by 3, that is 1 by 3 into R1. So it become 1, 1, 4 by 3, 20 by 3, rest of the elements as it is. Bring 0 below it, R2 minus R1, R3 minus 2 times R1. Okay, so do that operation. Second equation minus first equation, third equation minus 2 times first equation. That is nothing but these two row operations. Okay, 1, 1, 4 by 3, 20 by 3 as it is. Then this will be 1 minus 1, 0, 1 minus 1, 0, 1 minus 4 by 3 is minus 1 by 3, 6 minus 20 by 3 is minus 2 by 3. 2 minus 2 times 1, 1 minus 2 times 1, 3 minus 2 times 4 by 3, 13 minus 2 times 20 by 3, like that gives us this next row. Okay. Now, after getting 0 below it, remove that, means don't consider first row and first column. In the second column, check which is having the largest value. Okay, numerically largest value, that is the absolute value. Absolute value means modular, means just consider the positive term. Now absolute value of 0 is 0, absolute value of minus 1 is 1. So out of these two, numerically largest value is this. Okay, absolute value of this is plus 1, absolute positive value of this is 0. So out of this, numerically largest value is for third row. So we have to bring it here, and that we can do by interchanging second and third row. Okay, while considering the maximum value, we consider the modulus of that, absolute value of that, positive value of that number. Okay, so positive value of this 0 and minus 1, in that the positive value 1 will be the largest. So we interchange second and third row. So it gives us 0 minus 1, 1 by 3, minus 1 by 3, 0, 0, minus 1 by 3, minus 2 by 3. Now, bring this second row, second column, and element 1. 0 is already there. If you want, you can make it 1, or you can keep this minus 1 by 3 as it is. Anything you can do. Okay. So if you want 1, no problem. That gives us answer in less number of steps. Okay, so you can multiply this by minus sign, second row by minus sign, and if you want to make it 1, multiply this third row by minus 3. Okay, this minus 3 R3, this is optional operation. If you want, you do it. Otherwise, you can keep the terms as it is, no problem. Okay. Now whether we got the upper triangular, yes, this is upper triangular. From this also you can solve the system. This is upper triangular, so from this also you can write the matrix equations and solve that system. Okay, but if you make it one, then calculation get reduced. Further calculation get reduced. So uh, uh, we are done this all the coefficients one. Now from this write down the equations. First column will be the coefficients of x, second column are coefficients of y term, third column are coefficients of z term, and all these are the constant term. So we get the equation 1 into x plus 1 into y plus 4 by 3 into z equal to 20 by 3, 0 into x plus 1 into y minus 1 by 3 into z equal to 1 by 3, 0 into x plus 0 into y plus 1 into z equal to 2. So from last equation, directly we get z equal to 2. Put it into previous equation that gives us y. So y will be 1. Put it into both a y and z into previous equation that gives us x. That will be 3. So the values of x, y, z are 3, 1, 2. So what we have to do in partial pivoting, we have to bring the largest coefficient, which are equation having the largest coefficient, that equation we have to make it 1. After getting 0 below it, in the rest of the equation which is having the largest, that equation will be 2. Like that we have to simplify. Okay, and get upper triangular and writing the equations from it, solving that equation, we can get x, y, z. Okay, so it is the actually similar to Gauss elimination only. We just have to interchange the equations accordingly. Now consider the next method, second method, that is triangular factorization, or it is also called as a LU decomposition method. Okay, this is also very easy. What to do? First of all, our equations we are given, convert it into matrix form. That matrix form is nothing but Ax equal to B. Then we can write matrix A as a product of two matrices. One is lower triangular matrix denoted by L, and another is upper triangular matrix U, such that A is equal to L into U. We can factorize A into two matrices. One is a lower triangular matrix, another is a upper triangular matrix, such that A is equal to L into U. Now, what is the lower triangular matrix? All the elements above diagonal elements are 0, and upper triangular elements, all the elements below diagonal, below this are 0. The form of L, the standard form of this lower triangular matrix, where A can be split into two parts, is like this: 1, 0, 0, L21, 1, 0, L31, L32, 1. All the diagonal elements are 1 for this lower triangular matrix. Above that are 0. This is L21, L31, L32. U is U11, U12, U13, 0, U22, U23, 0, 0, U33. Okay, so these are the two matrices, lower and upper triangular matrix, whose product is nothing but A. And if we can write in that way, then as Ax equal to B, we replace A by L into U. We replace that A as a product of lower and upper triangular matrix. So L into U into X will be B. Now replace this U into X by Z term. Replace this Ux by Z. So what happens? L into this Z become B. Okay. Now just put the values of just use that L, find the values of Z terms. Putting that Z over here, we can get the values of X term. Okay, so by doing firstly solving this system, we can get Z, and by putting that Z here, we can get the values of X term. Okay, so this is the L which we get from matrix A. Put it into this equation. Get the equations from it: 1 into Z1, 0 into Z2, 0 into Z3, equal to B1. So directly we get value of Z1. Okay. Then using the second equation, equating with B2, putting the Z1 over here, we get Z2. And by using this third equation, we get the value of Z3. Okay. Now using this Z1, Z2, Z3, Z means this column matrix, use that Z1, Z2, Z3 in the second equation, Ux equal to Z. Okay. Put that value into Ux equal to Z. So it becomes U11, U12, U13, 0, U22, U23, 0, 0, U33. And putting this Z1, Z2, Z3 here, writing the equations from this matrix, we get U11 x1 plus U12 x2 plus U13 x3 equal to Z1, 0 x1, U12 x1, x2, U23 x3 equal to Z2, 0 x1, 0 x2, U33 x3 equal to Z3. From last equation, we get x3, put it into previous, that gives us x2, put both this into this, it gives us x1. Okay, so x1, x2, x3, we can obtain. So what to do? Firstly, we have to write A as product of L into U, then replace Ux by Z. It become L into Z equal to B. Then first solve this, get the value of Z. Then put Z here and solve this to get X. Okay. Now how to get this L and U? Because we know only A. How to get L and U? How to get this L21, L32, all these elements. So for that, we have to consider the matrix A as product of that two matrices. And we know how to take the product of two matrices. Making use of that, we can get the values of all this matrices L and U. And using LU, we can find first Z, and using Z, we can find X term. So A is that given matrix, write it as product of L and U. Now we take the product of two matrices. If you want to find the first row, first element, then take the first row of this, take first column of this. Okay, that gives us 1 into U11, 0 into 0, 0 into 0. That will be this first entry. For finding this element, position of this element is first row, second column. So take the first row of first matrix, take second column of second matrix, and take the product. 1 into U12, 0 into U22, 0 into 0. That gives us this element. Position of this element is first row, third column. Take first row of this, take third column of this. Take the corresponding multiplication. Add them to get this element. Position of this element is second row, first column. Take second row of this, first column of this. Multiply them and add them. It gives us this element. Like that, do the this multiplication. Okay, and equating this product with given matrix. A is the given matrix. We can get it from that system. So equate each of this element with this element. First element, this with this. First row, second element with first row, second element of this. So equate with the corresponding elements. That gives us 9 equations. Okay, and solving that 9 equations, we can find all the values of L and U. And after getting L and U, first find Z, and after getting Z, find X terms. Okay, it seems to be lengthy, but when we solve the problem, you understand it is very easy. Here we doesn't require any row operations, nothing. Okay, just properly solving that equations for L and U and getting that two matrices, upper triangular matrices. Properly get these two upper and lower triangular matrices, and then get the values of Z1, Z2, Z3, and X1, X2, X3 can be obtained from it easily. Okay, it seems to be quite lengthy because of these notations, but you see the problems. From that, you can easily understand how easy it is. So consider the first problem. Solve the following system of equation by using LU decomposition method. X plus Y plus Z equal to 1. 4x plus 3y minus z equal to 6, 3x plus 5y plus 3z equal to 4. Okay. So firstly, write down the matrix form. All the coefficients 1, 1, 1, 4, 3 minus 1, 3, 5, 3. X, Y, Z, and all the constant terms 1, 6, 4. So firstly, write what is A. Then that A can be written as product of L into U. So this is A, 1, 1, 1, 4, 3 minus 1, 3, 5, 3. L will be the lower triangular matrix. This is a fixed format 1, 0, 0, L21, 1, 0, L31, L32, 1. And upper triangular matrix, the format of upper triangular matrix is U11, U12, U13, 0, U23, U22, U22, U23, 0, 0, U33. Okay, we are splitting it into lower and upper triangular matrix, and that lower triangular matrix is of this form where diagonal elements are 1 and upper triangular is of this form. Okay, so this is L and U. So we are splitting it, we are decomposing it into L and U. So because of that, this method is called LU decomposition. Okay, now take the product, multiply first row to first column, equate it with this first row first column element. Then to get this first row second column element, take first row of this, take second column of this to get this element. Like that, we get 9 equations. So what is the first equation? 1 into U11, 0 into 0 plus 0 into 0, that will be 1. So this is the first equation. Multiply first row to second column. It will be 1 into U12, 0 into U22, 0 into 0. That will be equal to first row second column element 1. Multiply first row with third column. 1 into U13, 0 into U23, 0 into U33. That is equal to first row third column element, that is 1. Now take the second row first column and equate with the second row first column element. Then take second row second column element, second column, multiply corresponding elements, equate with second row second column element. Then second row third column, whatever equation we get, equate with second row third column element from this matrix. So we get the equations like this: L21 into U11 plus 1 into 0 plus 0 into 0 equal to 4. L21 into U12, 1 into U22, 0 into 0, that will be equal to 3. Like that, second row third column, it gives us equation which is equal to -1. Now take third row first column, third row first column, whatever equation we get on this side, equate with 3. Third row second column, U31, U12 plus U32 into U22 plus 1 into 0, equate with third row second column element 5. Like that, we get 3 more equations. L31 U11 equal to 3, L31 U12 plus L32 U22 equal to 5, and L31 U13 plus L32 U23 plus 1 into U33 equal to 3. Okay, so that gives us the last equation. Now solve this equation. First 3 values we get directly. Put this value here. That gives us L21 equal to 4 divided by 1. That is 4. Put these 2 values over here. U12 is 1. L21 is 4. So 4 into 1 is 4. Take 4 to other side. U22 will be -1. 3 minus 4, that is -1. Like that, put these values into these equations. So that gives us these terms. L21 will be 4. U22 will be -1. U23, substituting this previous value here, that gives us -5. L31 will be 3. Okay, putting U11 as 1 here, we get L31 as 3. L32, put all the values here, that gives us -2. And putting the values of these 4 terms, we get U33 equal to -10. Okay, simple substitution is there. it seems to be 9 equation, but this gets solved directly just by using previous values. 3 values we get directly. Putting this value into next, we get these 3 remaining equations, and putting all the 6 value into this, we can get the other 3 equations. Now, put these values of L and U back to this matrices. So the matrix L will be 1 0 0 4 1 0 3 minus 2 1, U is 1 1 1 0 minus 1 minus 5 0 0 minus 10. And now use the formula of A as L into U. Write down the equation in terms of Z and simplify it and put the value of Z to get X term. So we are using A into X equal to B, but A is L into U. So it is L into U into X equal to B. Take UX equal to Z. So L into Z equal to B. We know what is L. Take this L. Take Z as Z1, Z2, Z3. We know what is B. B is the matrix which we get from the system, all the constant terms. This is already there. We get from the problem, constant terms on the right hand side. Now get the equations from it. 1 into Z1, 0 into Z2 plus 0 into Z3 equal to 1. 4 into Z1 plus 1 into Z2 plus 0 into Z3 equal to 6. 3 into Z1 minus 2 into Z2 plus 1 into Z3 equal to 4. So you get 3 equations from this. Z1 is 1, 4Z1 plus Z2 equal to 6. We get these equations. From this we get Z1, put it here, that gives us Z2. Put Z1, Z2 here, that gives us Z3. Z1 is 1, Z2 is 2, Z3 is 5. Now, make use of this equation, U into X equal to Z. So we know what is U, X that we want to find, and Z are these terms, 1, 2, 5. Okay, so U into X is Z. So that is 1, 1, 1. 0 minus 1 minus 5. We are using this U. 0, 0 minus 10. X1, X2, X3 equal to 1, 2, 5. Write down the equations from it. 1 into X1 plus 1 into X2 plus 1 into X3 equal to 1. 0 into X1 minus 1 into X2 minus 5 into X3 equal to 2. 0 X1, 0 X2 minus 10 X3 equal to 5. And now from last equation we get X3, 5 by minus 10, that will be minus 0.5. Put that X3 into previous equation, that gives us X2. Put X3, X2 into this equation, that gives us X1. So the answer is X1 is 1, X2 is 0.5, X3 is minus 0.5. Okay. So what we have done in this problem, firstly we split A into 2 parts, L into U. Standard format are there for L and U. 1 0 0 L21 1 0 L32 L31 L32 1, and standard format for U, U11 U12 U13, all that format. Then we take this equation, L into U into X equal to B. Okay, out of that we put Ux equal to Z, it becomes Lz equal to B. Using Lz equal to B, we get Z1 Z2 Z3. Putting that into this, we get X1 X2 X3. Okay, so important is getting L into U first, L and U, then using that finding Z, and using Z finding XYZ. Okay, so it seems to be lengthy, but it is easy. Simple equations we get by that, and we can easily find the values of unknown terms. Okay, no row operations required for solving this problem. Okay, consider the last problem. Solve the following system of equation by using LU decomposition method. 10x plus y plus z equal to 12. 2x plus 10y plus z equal to 13. 2x plus 2y plus 10z equal to 14. Firstly, write down the matrix form. Coefficient of x in first column, coefficients of y in second column, coefficient of z in third column. Unknown terms in one column, and all constant terms 12, 13, 4 in one column. This is matrix B, Ax equal to B. Take a matrix A, write it as a product of L into U, These are standard formats for L and U. Multiplication also gives us the same product. Only these values of A11, A12, all these values are different. Otherwise, this product will be throughout same. Okay, always we get the same type of equations. First row gives us directly value of U11, U12, U13. This is U11, U12, U13. Okay, then second row gives us some more equations by taking the product of third row, and these columns gives us other three equations. Solving this equation, we get L21 equal to 0.2, U22 equal to 9.8, U23. Okay, and substitute into previous equation, it will be L31 is 0.2, L32 0.18, U33 9.65. Now put all these 9 values into these equations. By that we get L and U. Okay, so L and U will be these matrices: 100, 0.210, 0.2, 0.18, 1. U will be 10, 11, 0, 9.8, 0.8, 0, 0, 9.65. Okay. Now as A is LU, put that LU over here. It become LUX equal to B. Substitute UX equal to Z. So we get UX equal to Z. LZ become B. Then take this L, multiply with Z, that is Z1, Z2, Z3, equate with the constant matrix B, 12, 13, 14. Okay. Solve these equations, take the product of these two matrices, equate with these. We get three equations. Solve these three equations, gives us Z1, Z2, Z3. Put this Z1, Z2, Z3 into UX equal to Z. Okay. Use the other equation, UX equal to Z. All these three equations we get. From last equation, we get x3 equal to 1. Put it into previous, that gives us x2. Put x2, x3 into this, that gives us x1. So if we solve that three equations, it gives us x1 equal to 1, x2 equal to 1, x3 equal to 1.